All right, welcome geometry students. Go ahead, turn your books to lesson 72. That is page 477. We're gonna learn about tangents and circles, part 2. This lesson is talking about the tangents. Tangents are simply just outside lines that touch the circle at one point. So they're lines basically. Here we have two types. We have external, they're on the outside. Internal, they're kind of crisscrossing. And according to the theorem of this lesson, it says tangents are congruent. So here, if it's these two type of cases, those tangents are congruent, meaning they are the same length. So here, example 1, we have some sort of two tangents in a circle. They intersect at one point. We don't know if they intersect evenly at a certain point. Sorry, I have a message. All right, so they intersect at a certain point here. So now we have to go ahead and find what is MQ, and that is this section right here. So all of these here, these are the points where the line and the circle touches at that one exact point. It's not like several points, it's just at one point. Here, according to what we know, we have two lines going this way and that way. They look like there's different lengths, and you have to treat them like they're different lengths. So here, these two parts, when they intersect, the two lines on the outside here, these two are congruent, while these two are congruent as well. We're trying to look for what MQ is, and MQ is 2x minus 10. All we have to do is find what x is, and then we can find what this measurement is. So here, these two lengths are similar, they're congruent, and these two are congruent. Since they intersect at one point, we don't know if they intersect evenly. Like if this line was 10, we don't know if it intersects right at the middle where it's 5 and 5. But we do know that these two sides are exactly the same and these two sides are exactly the same. And when you add the two lines together, you do get the same amount for each one. Well, it's just because we don't know if they intersect at the middle. We don't know if this whole line is equal, it's congruent. That's why this is not congruent to this. Now looking at this though, we can see from looking at these two sides here, we know we can easily find x. We know that these two parts are congruent. That means if this is 12, this is equal to 12. What that means is QN is congruent to QR. QN is x, QR is 12. So you set them equal to each other. In this case, we already set them equal, we already solved for what x is. Now we can go back and solve for what MQ is. So MQ is 2x minus 10. Now we have what x is. X is 12. And then you go ahead and minus, and then you subtract and you get 14. And that's your answer. If you want to double check to see if they are congruent, if you take this, x plus 2, and if you put in place of x, so 12 plus 2, you end up with 14. So that means these two are congruent as this one is congruent as well. So whenever you're looking for equations, always look at what they're asking you for. They're only asking you for that small part. And in most cases, you're going to have an x. You have to find different ways to solve for that x. Example 2. This is where we have some sort of a weird tangent, and we have triangles in place of here. I'm not going to read the whole problem, but here they said the radius of circle Q is 5 centimeters. So a circle is always named by their center point. So it's a center point to one of the outside lines that's called a radius. So we have this line here is from the center to the outside part of the line. We know that the radius is 5. This small segment here is 5. But if we also look up here, this line is going from a center, and it has to be from the center in order for it to be a radius. So it's from the center to the outside portion, and therefore that is 5 too. Now let's look at the smaller circle. Here it says the radius of circle M is 2 centimeters. That means radius is from the center point to the outside. The diameter is the whole thing here. So the radius is from the center to the outside line. This is 2. From the center to the outside line, this is also 2. Here it says find the area of the triangle. We have to find different ways to solve for that triangle. If I were to take that triangle out, I have 5 here. It looks like I have this whole line. I have a measurement here. So this is 5 plus this portion here is 2, so that's 7, plus adding another 2, this is 9. Another thing we need to know about tangent, this is considered a tangent, so it kind of like crisscrosses into the circle. And when it does that, it creates a perpendicular line when it crisscrosses, especially when there's two lines intersecting at one point. So this line is intersecting this line right here, and this is considered a tangent line. It goes inside and it goes outside. So therefore that creates a 90-degree angle. This looks like it could be a 90-degree angle. We don't know if it's a 90-degree angle, but according to one of the properties of tangent lines, if there's a tangent line and there is like a radius or diameter and they intersect it, they always create perpendicular lines. Now looking at this, we have 5, we have 9, we don't have this. Here it says find the area. Whenever you're looking for areas of a triangle, it's 1/2 times your base times your height. The bottom portion of the triangle will be considered your base. This triangle is upside down, so if I were to flip it back up, this is considered the base and the height is considered 5. So what we're looking for now is what the base is. This is a right triangle. We can apply the Pythagorean theorem. 5 squared plus the other side squared is equal to the hypotenuse squared, and 9 is the hypotenuse. You can't just do 5 times 9 times 1/2. There's always work that is required. This is 25 plus x squared equals 81. Get x squared by itself, and that is 56. Square root both sides. And now here, it looks like the square root of 56. You can simplify it. You can put it in decimal form because they want an exact number. But if I were to simplify this radical, just for practice, we find factors of 56, with one of them being a perfect square. And I could think of 4 and I think it was 14. Yeah, 4 and 14. And that simplifies to radical 14. Now we can finally go ahead and solve for the area of a triangle. Area is equal to 1/2 times your base, which is 2 radical 14, times your height, which is 5. You multiply all those three numbers together, and they want it in terms of decimal form, so you're going to multiply the radical with it, and you are going to get about 18.7 cm squared. Again, for your homework, make sure you're only writing the number. Do not put cm, do not put cm squared. It messes up. I have to go back and change it. I do look at all the answers. It's just easier just to put the answer in the number form. Last one, we have that circle. There is a word problem to it. It looks like it's dealing with pulleys. A car has a timing belt that consists of 2 pulleys and a belt. So those 2 things. The belt runs around the 2 pulleys and is tangent to both of them. Meaning, look at these lines here. They are creating a tangent lines that meet at one point. According to the theorem we learned back then, maybe last week I think, if the 2 lines intersect at one point, they are congruent. So that means here, this is the same distance as here because they are at the same exact measurement, and plus they're tangent lines. They're meeting at the same part of the circle, especially because they're meeting at one point. So now, what they're saying here is find the measurement of the section of the pulley. So here is just dotted lines, but here's where the exact pulleys, it's like a circle. Think of an actual belt. It's going around and around and around. We have to find the measurement for those. Because of the fact that these 2 outside lines meet at one point, that makes the 2 tangent lines congruent to each other. So that means IH is congruent to KL. This is the same exact measurement as this. IK is 1/6x plus 1, and KL is x over 2. If they are congruent, they are equal to each other. Just like example 1, they are congruent, they are equal to each other. Now we go ahead and solve for it. Here we have this, some sort of like a fraction. There's 2 or 3 different ways you can do these type of problems. For me, I want to get rid of all the fractions just to make it easier to solve for x. So I have 1/6, I have a denominator of 6, I have a denominator of 2. I find the least common denominator, and that would be 6. So if I multiply the whole equation by 6, I end up with 6 times 1/6 gives me x. 6 times 1 gives me 6. 6 times x over 2. So think of 6 times 1/2. Or 2 can go into 6 3 times. And now I have just one basic set of equations. You could just move the x over here, you have to multiply the 2 and then move the x's around. You could do that too, but I think this way is easier. Now, you solve for x, move the x over here. So this is 2x equal to 6, divide 2, and x is equal to 3. We're not done yet. They want to find the measurement of each of those belts from the 2 circles, from the 2 wheels. What we do now is we have to plug it in. X divided by 2. Now we have what x is. It's 3 divided by 2, which is about 1.5. If you want to make sure to see if you did it right. All right, let's go back to that. Here we are solving 1 over 6 times 3 plus 1. So 3 can go into 6 2 times, and that gives you 1/2 plus 1, and that will give you 1.5, and they are the same measurement, and that's what your answer should be. So you're using the different properties to see why they're congruent. A lot of these different things in geometry is basically, are they congruent? So you set them equal to each other. Do they both equal 180? Do they both equal 90? Or what? So you're always looking for what x is. So if you need any help with your homework, let me know down there. Thank you.